Now in this question it says that the x, y, z are three positive real numbers and they are governed by this particular expression, and we have to identify that which of the given options are correct. Normally we have to identify whether x, y, z are in GP or AP, and if they are in GP or AP, then in what order they are. So let us first of all simplify this equation. So I can write this as 9 into 25x square plus 9y square plus 25z square minus 25 into 3zx is minus, I'm just taking this portion to the LHS, so it will be 15y into 3x minus 15y into z, and that is equal to 0. Now if I observe that 9 is a square of 3, 25 is a square of 5, so I can write this particular expression, this particular term as 15x whole square, right? Similarly, this then can be written as 3y whole square, and this portion can be written as 5z whole square, minus again this particular term can be written as 15 times of x into 3 into 5 of z, right? We can observe that 15 into 3 is 25 into 3 is 75, which can again be written as 15 into 5. So I'm just using 15x and 5z so that it get aligned with this thing, right? The coefficient of x should be same, and similarly the coefficient of z should be same. Now here just to make the coefficient of y 3, I can write this as 15 times of x into 3y, and this thing can be written as say 3y into 5 times of z, and that is equal to 0. So if I take 15x to be say A, 3y to be B, 5z to be C, then we can see that this particular term is AC, right? This term becomes AB and this term become BC, right? So let me just substitute it so that the expression becomes simpler. So this thing can again be written as A square plus B square plus C square minus AC minus BC minus CA, and that is equal to 0. Now I need to make the terms as a perfect square. We know that A square plus B square minus 2AB, in fact this term will be AB minus 2AB will be A minus B whole square, right? But here the coefficient of AB is only 1. Just to make it 2, let me multiply the entire expression with 2. So here I'll be getting 2 times of A square plus 2 times of B square plus 2 times of C square minus 2 times of AC minus 2 times of AB minus 2 times of CA will be equal to 0. Now again, if I take 1a square from here, 1b square from here, and 2ab minus 2ab together, then I can write it as a minus b whole square, right? Similarly, 1b from here, 1c from here, and 2bc, actually I have left it, this term should be bc, right? And 2bc, so it will be b minus c whole square plus the last term will be c minus a whole square, and that is equal to 0. Now if I observe the LHS and RHS, it seems that since the sum of the square of three terms is equal to 0, and that is only possible that each of these term is 0. So we have a minus b should be equal to 0, and b minus c should also be equal to 0, and c minus a should also be equal to 0. So in general I can say that a should be equal to b should be equal to c. Now substituting the corresponding value of ABC which we have assumed, so let me use this space. So we can say that 15 times of x should be equal to 3 times of y, and that should be equal to 5 times of z. So if I take these two equations, then the value of y would be 5 by 3 times of z. And if I take these two equations, then x would be 3 by 15 times of y, and substituting the value of y from here, I can write it as 3 by 15 into 5 by 3 times of z, or further simplification I can write it as 1 by 5 times of z. Now observe closely that 1 by 5 times of z plus 5 by 3 times of z, in fact this will be 3, I'm sorry, and 1 by 3 times of z and 5 by 3 times of z, if I add it, it will become 2z. Or I can say that y plus x, if I add, it will be 5 by 3 z plus 1 by 5 times 1 by 3 times of z, or equal to 6 by 3 times of z, or 2 times of z, right? So effectively we can see that x plus y plus x is equal to 2z, or z is y plus x by 2. So y, or in fact z, is the arithmetic mean of y and x. Hence, I can say that y, z and x, they should be in arithmetic progression, which is option C.